So two people are on a merry-go-round. Jane is sitting 9 feet away from the center and Bill is sitting 5 feet away from the center. Who is traveling faster? Jane claims she's moving at a faster speed, but Bill thinks, no way, we're going the same speed. Who is correct here? Think about it, pause and make a guess, and then watch the rest of the video to find out the answer. So what is the answer to this question? It turns out they both can be correct. How is that possible? Well, we have to look at what we're talking about. Are we talking angular speed or are we talking linear speed? You see, Bill claims their speeds are the same because Bill is focusing on how much spin or angle they spin it per unit time. If you think about it this way, right, let's suppose that the wheel spins 360 degrees every 5 seconds. If that's the case, then Bill and Jane both spin 360 degrees in 5 seconds, so that's 72 degrees per second, which is the same for both. So both Bill and Jane have the same angular speed. But Jane is looking at linear speed. If you look at linear speed for a second, Jane says, look, I'm going to calculate my circumference I travel per every 5 seconds. We travel one circumference, that's 2 pi 9 feet every 5 seconds. That's 11.3 feet per second. That's Jane's linear speed. Contrast that with Bill's. Bill is going a lot slower, isn't he? Because since he is a shorter distance away from the center, the circle that he spins is going to have a lot less distance to it. The circumference of that circle will be less than Jane's bigger circle, right? So Bill's linear speed is only 6.28 feet per second. So in this case, both are right. And when I teach linear and angular speed in algebra class or pre-calc, this is how I love to intro the problem to students. I give them this problem and I ask them to figure out who is correct, and then we discover, wow, they both could be correct. It all depends on the context or what particular thing we're talking about.